Good morning, class.
Good morning.
Good morning.
Today we're going to be doing the instructional routine Contemplate and Calculate. When we're doing Contemplate and Calculate, we're going to be focusing today on looking for shortcuts with counting and area, how those things kind of connect. The reason we're doing that, we want to think like mathematicians. We really want to focus on the mathematical structure that you can use to build your shortcut, to make your thinking efficient. Okay, so we've got 4 major steps. 2-hour routine, you're going to notice details. You're going to find a shortcut. You're going to get to share and study those shortcuts together. And then at the end, we'll have a chance to reflect on the learning that happens. I'm going to show you a picture in a moment for a really, really brief amount of time, maybe a second and a half. So you want to make sure you're looking right up at the board. And you want to ask yourself, what is mathematically important? All right, is everybody ready? Now, I don't want you to be writing anything down. I want your whole focus right now to be on the screen and a little bit later talking to each other, but no writing. All right, you ready? 3, 2, 1. All right, take a moment to share with your group, with your partner. What did you notice that was mathematically important?
Sections. One is on that section. The last section. And there's in between the circle, there's empty space.
I noticed there was almost like symmetry to the pattern of how the circles were laid out. It appeared like there was a rectangle and a rectangle and then a rectangle and like another rectangle. And the circles are made up like a bigger shape.
I don't know if they're the same size.
I feel like the circles were arranged in a rectangular array. But
All right, I'm going to interrupt. I need everyone's eyes up front. And I'm going to ask you just to share out some of the details that you noticed that are mathematically important in that image. Can I have a volunteer get us started? Okay, go ahead.
we noticed that there were circles making up like rectangular arrays that were attached.
I'm going to do shorthand, okay?
Sure.
As you guys share out, try and share one detail at a time. Try and be as specific as possible, okay? Who else has a noticing for me? Francesca, go ahead.
I noticed that they weren't perfect rectangles. Like there was an extra circle making it a little off.
Okay. Aaron?
But the circles were organized in like rows and columns.
All right. I do that all the time. Maxine, go ahead.
We noticed that the circles were the same size, and I noticed there's a group at the bottom seam and then a group at the top.
All right, this sounds great. It sounds like you guys have noticed some details that feed into our mathematical structure, some things that are going to help you find shortcuts today. So, I'm going to ask that you all, I'm going to show you the image in a minute, but I'm going to ask that you all take a moment by yourself, so completely quiet, without writing, without talking, to think about how you can answer this question the most efficiently. Find the number of circles in your head without counting all of the circles. Now you each have a partner. I want you to start to share with your partner. What did you notice and how is it helping you kind of get into your shortcut?
Yeah, I think one is like, and group them into two. I saw that it's a chunk of 4 by 3, and there's another chunk of 4 by 3 from there, and there's 3 isolated ones. So I just find that since I know that 4 by 3 is 12, another 4 by 3 is 12,
Yeah, I thought about it that way at first also. Yeah, although I thought about it as double, so I did 12, and then added the 3. But I also realized that we can take those 2 and make an extra 3 at the bottom, and then think about it as a 3 by 3, which is still 12, plus a 3 by 5, which is 15, and then 15 plus 12 is the same 27. So I can add 2.
Is there a way that can we move that also to that side? Use it, like remove all this to this side.
Oh,
Yeah,
you know, we could just scoot it over and make it a 4 by 7. You could make it a 4 by 7 too. And then it's still, wait. No, it's 4 by 7, but it's missing. Yeah. So we could do that too. So we just said that we could also smush the rectangle over to the left so that it lines up with that one, and then move that over, and then there's one missing in 4 by 7, which is 28 minus 1.
If you can share
All right, I need everyone's eyes back up front. So I've given a couple people a heads up that I'm going to have them share their strategy, and some of you have had the same strategy, which I think is really cool because you're spread out around the room. When our volunteers our voluntold people are sharing their strategies, I need everybody else in the room to really be focusing on what they're saying. I'm also going to stand up here and I'm going to try and point to help us kind of see the strategy that people are sharing. The reason I need you to be listening and focused really on the share out is I'm going to need someone else to restate the share out when they're done. And only then am I actually going to take notes on it. Okay? All right, David's going to actually get us started. And David, I have some prompts up here for you to kind of connect back to our noticings. So whenever you're ready, you can go ahead.
All right, so I noticed that because they are grouped in chunks, like I look at the circles as 2 chunks. So that part on the top is a group of 3 by 4 array, and then the down one is also 4 by 3. So since they are 2 groups, I know that 3 by 4 is the same as 4 by 3. So when I multiply the 2, I had 12 times 2, twice of it will be 24. And after seeing that, I saw that there's 3 isolated ones, so I just added a 3, and that made it 27.
Okay, very good. Can I have a volunteer kind of restate David's strategy there? Erin, go ahead.
So we noticed that there were the 2 chunks of circles, and in both of them there was a 4 by 3 or a 3 by 4, which he knew would leave 12. And then there were 2 of them, so that was 24. And then there were 3 extra circles, which he just added separately to get 27.
Okay. David, how did she do?
Yeah, that was good.
Good?
Yeah.
Okay, cool. Let's see. I think, Francesca, can we have you share next?
Sure.
All right, so Francesca's going to share. Again, I'm going to point, and I'm going to need someone to restate Francesca's share. Go ahead.
I tried to reorganize the circles so that I would have 2 nice shapes to deal with. So I saw what David saw with the rectangles on the inside, but I took the 3 extra circles and the 2 that are sticking out in the middle, I moved those to the blank space at the bottom chunk. And so that left me with a 3x4 rectangle at the top, which is 12, and a 5x3, which is 15, and 15 and 12 is 27.
Okay, great. Can someone restate that strategy for me? Becky, thank you.
What she noticed was that she wanted to first make them into more compatible shapes, I guess. And so she saw the different parts of each circle, and then she saw that there were 2 circles on each side of the shapes that needed to be rearranged. So she brought them down to the row of circles that were connecting the 2 other parts. And then with that, she had 4x3 on the right-hand corner, and then 5x3 on the bottom left corner. And so 4x3 is 12, and then 3x5 is 15, and then she added them up and got 27.
Very nice. We good with that? Okay. And Kit, you're going to be our last person to share this strategy. Now, if you haven't participated yet today, this is your chance, right, to get some participation in. Kit, go right ahead.
So I actually started with both of the strategies we heard so far, and then I started thinking about how else I could rearrange it. And I thought about that 3x4 on the top. If I just shoved it over to the left, I could make one big rectangle if I took that extra circle on the bottom right and like moved it over to the left side. And then I realized that it was a 4x7, but there was one missing. Right, exactly. And so then I did 4 times 7, which is 28, and took away the 1 to get 27.
Okay, great. Now, this one's going to be harder for me to draw. But I would love if someone could restate Kit's strategy. Can you already have it?
So Kit, I'm sorry, Kit. So Kit wanted to combine 2 chunks of the shapes into one big rectangle, and so he moved the top right-hand corner shape to the left to make a 4x7 big rectangle, but there is a missing piece, first column towards the top. So he took 1 from 4 times 7. 4x7?
Kit, is there anything that you would change or add to that?
I mentioned moving that extra circle on the bottom over to the left side so that it filled in one of the 2 empty spaces.
Okay, cool. And so the empty space is really, I guess I'll leave this as a negative space. Okay, wonderful. So at this point, I've lost my clicker. At this point, I want you guys to really think about this experience that you've had today in class. And I want you to think about how you might use some of these strategies moving forward. So you can finally pick up your pen or pencil. And in your booklet, actually, there's a page for you to write the first meta-reflection. You can choose either of these to respond to, but I really want to make sure that you connect them back to this activity. So take a moment on your own to respond to that meta-reflection. And again, choose one. All right, take a moment to finish up. And I've got two people who are going to share their meta reflections out. And then if there's anyone else who has something very different that you think also needs to be surfaced, you can share as well. Francesca, can you share first for me?
You can find strategies for counting by rearranging parts of a diagram to form more familiar shapes and using area to find the total.
So easier to count if you can rearrange and use area. And that actually makes me think back to your notices. You guys talked about the different groups, right? I was hoping that somebody would say something about the groups of circles that you saw. So that's wonderful. And Maxine, can you share yours for me?
I said paying attention to groups of similar shapes in a visual is important because it helps you add large quantities faster to find the total area.
And that's our goal, right? We want to be as efficient as we can be. And so if you can add some numbers together without having to count each individual circle, then you're going to be a more effective mathematician. Is there anyone else who really wants to share their reflection? Anything that feels different than either of these? Okay, wonderful.